Let's start deep-sea exploration. 1. The mystery of the bloop. In 1997, scientists at the U.S. National Oceanic and Atmospheric Administration, NOAA, detected a low-frequency, ultra-powerful sound deep in the Pacific Ocean. This mysterious sound, later dubbed the bloop, was captured by underwater microphones positioned thousands of miles apart. What made it truly remarkable wasn't just its volume, but the fact that it bore a resemblance to the audio signature of a living creature. At first, scientists were baffled. The bloop was picked up across a vast expanse of the ocean, and it was far louder than any known biological or geological source at the time. To put this into perspective, the bloop sound could be detected from over 3,000 miles away, an unusual reach for underwater sounds. Researchers estimate its peak volume to be 240 decibels, far surpassing typical marine sounds like those produced by sperm whales, which reach around 230 decibels. That's louder than a jet engine at takeoff. This sparked widespread speculation that the sound might have been generated by an unknown marine animal, perhaps even one far larger than a blue whale. This idea, though compelling, raised significant questions. Could there be a creature of that size lurking in the depths? If so, why hadn't we discovered any physical evidence? NOAA's sophisticated hydrophone network was originally built to monitor undersea volcanic activity and icequakes. Such networks have recorded many sounds, yet few match this intensity or distinct pattern, making the sudden appearance of the bloop all the more mystifying. Over the years, scientists have worked diligently to solve the mystery. The most widely accepted hypothesis today is that the bloop was caused by a cryoseism, or an icequake, resulting from the breaking up of massive icebergs in Antarctica. Icequakes occur when large chunks of ice suddenly crack and shift, producing seismic-like vibrations that can travel through water. Its duration and frequency closely match an icequake, which occurs when icebergs fracture and collapse into the sea. Icequakes have been recorded with frequencies similar to the bloop, usually ranging from 0.1 to 10 Hz, making them distinct from other geological or biological sources. The cryoseism hypothesis makes sense in several ways. First, the location of the sound, which was traced to a remote area in the South Pacific, is near known iceberg activity. Second, icequakes are powerful enough to generate sounds that travel across thousands of miles, explaining why the bloop was detected by listening devices so far apart. Marine acousticians speculate that subtle shifts in ocean salinity or temperature could have made the region unusually conductive for sound, elevating the bloop's volume. Additional oceanographic data from the same time frame hint at subtle fluctuations in deep-water currents, raising the possibility that multiple overlapping phenomena might have amplified the cryoseism's acoustic signature to create this once-in-a-century enigma. While this theory is scientifically sound, some argue that it doesn't fully explain the sound's organic-like qualities that initially led scientists to think it could be from a living creature. Could this mean there are undiscovered creatures capable of producing sounds on such a massive scale? Or is it simply a quirk of nature? While the icequake explanation has gained widespread acceptance, the allure of the bloop as an unexplained phenomenon persists. What keeps this mystery alive is the lack of any subsequent detections of similar sounds. If the bloop were simply the result of iceberg activity, it would be expected that other similar noises would have been recorded in the years since, but they haven't. Even with improved ocean monitoring technology, we haven't been able to isolate the exact conditions or location that led to the creation of the bloop. Despite years of research, we may never know the full story. While the bloop may have echoed across the ocean's depths, leaving us with unanswered questions, it's not the only thing to stir intrigue in the deep sea. Some mysteries come not from noises, but from the very earth beneath the ocean floor. 2. Underwater brine pools, toxic lakes hidden beneath the sea. These strange geological events remain equally elusive, and none are more puzzling than the underwater brine pools, an otherworldly phenomenon that challenges everything we know about marine environments. These pools, first discovered by submersibles in places like the Gulf of Mexico and the Red Sea, are so dense with salt and chemicals that they behave almost like liquid mercury, creating lakes within the ocean itself. What makes these pools especially fascinating is their stark contrast to the surrounding seawater and their deadly effect on most marine life. Underwater brine pools are typically formed by the dissolution of salt deposits that were left behind millions of years ago when ancient seas evaporated. These salt deposits, buried beneath the ocean floor, mix with groundwater that seeps through cracks and faults in the Earth's crust, creating pockets of hypersaline water. This water is up to 5 to 8 times saltier than the surrounding seawater, making it much denser and preventing it from mixing with the ocean above. Instead, the brine pools form distinct lakes or rivers at the bottom of the ocean, often surrounded by sharp boundaries that resemble shorelines. One of the most well-known brine pools is found in the Gulf of Mexico, where scientists have discovered pools that are rich in hydrogen sulfide and methane gas. These chemicals seep up from beneath the seafloor, often through cracks in the Earth's crust known as salt domes. Salt domes are large, underground salt deposits that push upward, creating pathways for the brine to rise and collect in these submerged lakes. The unique composition of brine pools makes them some of the most inhospitable environments on the planet. The high levels of salt, methane, and hydrogen sulfide are toxic to most marine life. Submersible footage has captured eerie images of marine life wandering too close to the brine pool boundaries, only to collapse and sink into the depths, becoming preserved in the hypersaline environment. Marine geologists also suspect that changes in seafloor topography, caused by slow-moving tectonic shifts, can abruptly alter brine pool boundaries, leading to sudden influxes of toxic fluid that catch nearby marine life completely off guard. Despite their toxic nature, brine pools are home to specialized organisms known as extremophiles. These are microorganisms that have adapted to survive in the harsh conditions of extreme salinity, high pressure, and toxic gases. In particular, bacteria that metabolize methane thrive in these environments, forming the base of a unique ecosystem. These bacteria are considered analogs for possible life forms that could exist on other celestial bodies, such as the icy moons Europa and Enceladus, where similar extreme environments might exist beneath frozen oceans. Scientists often study these organisms to understand potential life in harsh off-world environments, gleaning insights into how life could persist under similarly extreme conditions elsewhere in the solar system. Brine pools are not just biological curiosities. They are also a subject of intense scientific study due to their geological and chemical significance. One of the most intriguing aspects of these pools is their potential as natural methane reservoirs. Methane is a potent greenhouse gas, and brine pools in regions like the Gulf of Mexico contain vast amounts of it. However, the extreme conditions of brine pools make any potential methane harvesting highly challenging. Furthermore, recent studies have shown that brine pools may play a role in the carbon cycle, as methane-consuming bacteria in these environments help mitigate the release of this greenhouse gas into the atmosphere. These bacteria perform a crucial ecological function by converting methane into less harmful compounds before it can escape into the water column and eventually the atmosphere. Despite decades of research, many questions about brine pools remain unanswered. For example, scientists are still investigating why some brine pools expand over time, while others remain relatively static, raising new questions about how variations in seafloor geology or fluid flow influence their growth. However, the deep ocean hides more than just toxic brine lakes and eerie dead zones. If you think lakes of poison are strange, wait until you see an entire ocean light up like the galaxy. Now, imagine sailing through vast stretches of glowing water, illuminating the night like a sea of stars. It's not a myth or a sailor's tale, but a very real and rarely seen phenomenon known as the Milky Sea. Let's dive into this enigma, where the ocean itself glows in the dark. 3. The Milky Sea phenomenon. When the ocean becomes galaxy. The Milky Sea effect, also known as Mareal or Noctiluca, is a phenomenon where large areas of the ocean emit a steady, uniform glow. Unlike the more familiar flashes of bioluminescence caused by plankton being disturbed by boats or waves, the Milky Sea is unique in its sheer scale and steadiness. Satellite imagery captured in 2005 revealed that one such event covered an area of 15,000 square kilometers, 5,800 square miles, about the size of Connecticut. Sailors who have encountered this phenomenon describe it as if the sea itself has turned into a glowing white or bluish liquid, visible even on moonless nights. The glow can persist for hours or even days. Despite these reports, Milky Seas are extremely rare and have only been documented a few dozen times in the last century. Most scientists agree that the Milky Sea is likely caused by bacteria such as Vibrio harvii, which live in the surface waters and produce light through chemical reactions. However, this explanation raises more questions than it answers. For instance, how do these bacteria coordinate to create such a massive, synchronized glow across hundreds of miles? One theory suggests that the bacteria might form symbiotic relationships with algae, which could provide them with nutrients, allowing the bacteria to proliferate and produce light on a massive scale. Another possibility is that oceanic currents and temperature variations could create the perfect conditions for these bioluminescent organisms to thrive and spread over large areas. However, there's no definitive explanation for the immense size and uniformity of the Milky Sea glow. This phenomenon also sets itself apart from other mysterious oceanic occurrences like the bloop or brine pools, which are rooted in geological or chemical processes. The Milky Sea effect, however, points to a biological origin, though it's unlike any other known bioluminescent behavior in the ocean. In recent years, satellite technology has allowed scientists to track and observe Milky Sea events more closely, but many fundamental questions remain. The latest research suggests that while the bacteria are key to the glow, there might be other environmental factors. Scientists tracking these luminous displays speculate that slight alterations in salinity or unrecognized planktonic cycles may trigger the expansive bacterial bloom, turning vast water columns into an otherworldly radiance, seemingly lifted straight from science fiction. It's one of the rarest and most extraordinary sights in the ocean. Yet science is only just beginning to scratch the surface of understanding it. What environmental conditions lead to such large-scale bioluminescence? Could this phenomenon point to undiscovered microbial ecosystems in the ocean? The answers are still out there, glowing faintly in the depths of the sea, waiting to be discovered. The sight of a Milky Sea glowing across the horizon is one of the ocean's most breathtaking mysteries, but the deep sea holds another, perhaps even more astonishing surprise: gigantic creatures that defy all expectations. These animals, far larger than their shallow water relatives, thrive in the crushing pressures and dark depths of the ocean. How and why do they grow to such enormous sizes? 4. Deep sea gigantism. Gigantic creatures in the crushing depths. This term refers to the tendency of certain deep-sea creatures to grow to extraordinary sizes, far larger than their shallow water relatives. While many deep-sea species are small and adapted to survive in environments with limited food and resources, take, for instance, the giant squid, Architeuthis dux, a creature that has captivated human imagination for centuries, fueling tales of sea monsters. The largest specimens ever recorded reached lengths of up to 43 feet, 13 meters, with eyes the size of dinner plates. These elusive creatures were once considered a myth, until physical evidence such as beached carcasses and deep-sea footage confirmed their existence. However, despite their size and occasional sightings, giant squid remain shrouded in mystery. Why do they grow so large in the crushing depths of the ocean? And how do they survive in an environment with such limited food? Scientists have put forward several hypotheses, but there's no definitive answer. One prevailing theory is that the cold temperatures of the deep ocean may slow down the metabolism of these creatures, allowing them to live longer and consequently grow larger. In these frigid depths, where resources are scarce, growing to a larger size might provide an advantage, enabling the creatures to store more energy for long periods between meals. Analysis of giant amphipods reveals an astonishing capacity for storing lipids, enabling them to survive prolonged food shortages more effectively than smaller counterparts. Another hypothesis is related to the immense pressure found at these depths. The ocean's pressure increases by 1 atmosphere for every 10 meters of depth, meaning that at extreme depths, animals experience crushing forces on their bodies. It's possible that growing larger allows these creatures to withstand the extreme pressure more effectively, though this theory is still a topic of debate. Interestingly, deep-sea gigantism is not restricted to squids alone. The Japanese spider crab, the largest arthropod on Earth, can have a leg span of up to 12 feet, 3.7 meters. Additionally, deep-sea isopods, which resemble giant pillbugs, can grow up to 20 inches, 50 centimeters long, compared to their much smaller, shallow-water relatives. Furthermore, specialized immune systems found in these oversized species suggest an evolutionary path tailored to ward off deep-sea pathogens rarely encountered in shallower waters. Deep-sea gigantism forces us to reconsider the limits of life. If creatures like the giant squid and Japanese spider crab can thrive in these extreme environments, what other unknown species might be lurking in the darkness, hidden from our view? As exploration of the deep sea continues, the mystery of gigantism and the creatures it produces remains an open question, leaving us with more questions than answers. The deep sea is home to many mysteries, strange sounds, toxic lakes, and creatures of unimaginable size. Yet, there's one final phenomenon that leaves both scientists and explorers equally baffled. Unlike the others, this isn't just a sound or a creature, but an entire structure deep in the ocean. It's a mystery that defies explanation, and some have even speculated that it could be evidence of something far beyond our current understanding. 5. The Bermuda Triangle of the Deep, submarines vanishing without a trace. A strange area in the Atlantic Ocean where entire submarines have gone missing without a trace. For centuries, stories of the Bermuda Triangle have captivated the imagination. Ships disappearing, planes vanishing into thin air. But what if there's something even more unsettling happening far beneath the surface? While the exact boundaries of the Bermuda Triangle are often debated, the oceanic abyss within this region holds mysteries that are just as puzzling. Unlike the folklore surrounding the skies above, these mysteries are backed by documented cases, entire submarines that have vanished without explanation. One of the most famous cases occurred in 1968 with the disappearance of the USS Scorpion, a nuclear submarine with a crew of 99 men. It was returning to Norfolk, Virginia, from a routine deployment when it suddenly stopped communicating. Despite extensive searches and the use of advanced sonar technology, the wreckage wasn't discovered until 5 months later. It was found at a depth of more than 9,800 feet, 3,000 meters, in the North Atlantic. To this day, the cause of the submarine's loss remains a mystery. Hypotheses have ranged from a torpedo malfunction to a Cold War confrontation, but no definitive evidence has surfaced. Similarly, in 1963, the USS Thresher, another nuclear-powered submarine, suffered a catastrophic fate. While conducting deep-dive tests off the coast of Massachusetts, it disappeared. The Thresher was found in pieces on the ocean floor at a depth of 8,400 feet, 2,560 meters. Despite thorough investigations, the exact cause remains uncertain. What could cause these submarines to vanish in such a dramatic fashion? One leading theory involves underwater landslides or submarine earthquakes. The seafloor within the Bermuda Triangle area is not static. Tectonic plates shift, and earthquakes occasionally occur, causing undersea landslides that could generate powerful tsunamis. These waves could easily capsize vessels or pull submarines to the ocean floor, where the immense pressure would crush them. Another natural explanation involves methane hydrate deposits on the ocean floor. Methane hydrates are ice-like compounds that trap large amounts of methane beneath the seabed. If these hydrates are disturbed, either by tectonic activity or warming ocean temperatures, they can suddenly release methane gas, which rises rapidly through the water. This sudden release could cause the water's buoyancy to decrease, potentially sinking ships and submarines. Known as the methane burp theory, this hypothesis remains controversial, but has been considered plausible for explaining rapid, unexplained sinkings in regions like the Bermuda Triangle. Another widely discussed theory revolves around magnetic anomalies in the region. Some researchers have proposed that unusually strong or weak magnetic fields in the Bermuda Triangle could interfere with navigational systems. The Earth's magnetic field guides ships and planes by affecting compasses and other instruments. If these fields are somehow disturbed or distorted, vessels could lose their sense of direction, leading to dangerous situations in the deep sea. However, the connection between magnetic anomalies and submarine disappearances remains speculative, as no conclusive data has emerged linking the two. The deep sea is an environment hostile to human technology. At extreme depths, the pressure is so immense that even the slightest mechanical failure can lead to catastrophic results. Submarines, particularly those operating in the mid-20th century, were susceptible to these pressures. The case of the USS Thresher highlighted the possibility that structural issues, whether it be welding failures, coolant leaks, or power outages, could lead to sudden and irreversible failures in the deep sea. Engineers studying historic submarine blueprints note that mid-20th century vessels frequently lacked advanced pressure-resistant alloys, meaning any unforeseen stressor, like a rapid methane discharge, could compromise structural integrity with lethal speed. Additional naval archives indicate sporadic pockets of high salinity within the triangle, a factor that could distort sonar returns and complicate submarine navigation. While the theories mentioned are grounded in scientific explanations, there are always more fringe ideas that capture the public's imagination. Some believe that the disappearances of submarines in the Bermuda Triangle could be evidence of extraterrestrial activity or even portals to other dimensions. While there is no scientific basis for these claims, the lack of concrete evidence has left room for wild speculation. The enduring mystery of the Bermuda Triangle keeps these ideas alive, even though they lack substantial proof. Despite decades of investigations, the Bermuda Triangle remains one of the most enduring mysteries of the ocean. As of now, no single explanation fully accounts for the vanishing submarines. With much of the ocean floor still unexplored, could it be that geological forces, methane bursts, or something entirely unknown is responsible for these disappearances? For now, the depths of the Bermuda Triangle hold their secrets tightly, leaving us with only fragments of wreckage and endless speculation. Whether it's strange sounds or creatures beyond imagination, every discovery leaves us with more questions than answers. And we're glad you were here with us to explore these wonders. Every moment counts, and you chose to spend yours with us. So thank you. To those of you who've already subscribed, thank you for being part of this journey. It means a lot. And if you haven't yet, no worries. We're just happy you've spent some time with us today. If you ever feel like diving deeper into dark history, or more unexplained phenomena, or learning alongside us, feel free to join. We are Freak Files channel that bring weird history and dark horror story to life via documentary. Thanks again for watching, and until the next mystery, stay curious.